Welcome to the DIY Honda Garage channel. The DTC P0617 specifically refers to an issue regarding the starter cut relay diagnosis circuit in the Honda Civic 2022 and newer models. This error indicates that the voltage level on the relay diagnosis line input is higher than acceptable when the starter is switched off. The vehicle's powertrain control module, PCM, detects this abnormal voltage and stores the DTC for future reference. Understanding the importance of each component involved is crucial for effective troubleshooting. The starter cut relay is integral to the vehicle's starting system, preventing unauthorized attempts to start the engine. The PCM plays a vital role as the vehicle's brain, processing inputs from various sensors and controlling outputs to ensure optimal engine performance. If the PCM registers too high a voltage in this circuit, it becomes necessary to diagnose the potential causes to restore proper functionality. The primary component affected by DTC P0617 is the starter cut relay diagnosis circuit, which is monitored by the PCM in the Honda Civic. The starter cut relay is located within the relay circuit board and is critical for controlling the starter motor's operation based on specific conditions. This relay facilitates the flow of power to the starter system, thereby ensuring that the engine can start as expected. The relay circuit board houses multiple relays, including the starter cut relay, and is typically found near the engine bay for easy access. The PCM, responsible for interpreting signals from various sensors in the vehicle, detects anomalies in the voltage levels, especially when the starter is not engaged. Additionally, the signal wiring that links these components is vital for accurate operation. Any faults here can lead to abnormalities that trigger the DTC. The causes of DTC P0617 can vary, but often include a short circuit in the relay circuit. This can occur when the wiring that connects the relay circuit board and the PCM has insulation damage or improper connections, leading to elevated voltage readings. Another possible cause is a faulty relay circuit board itself, which may be unable to correctly manage the relay operations due to internal damage or wear. Lastly, if the other components are functioning correctly, a defective PCM could be the source of the problem, as it may incorrectly read and process the voltage levels, resulting in erroneous DTC storage. Properly diagnosing these causes will be essential to determine the exact nature of the issue. Symptoms of DTC P0617 commonly include issues with the starter system, where the engine may fail to start despite attempts. This malfunction can be frustrating, as it may lead to complete non-functionality of the vehicle. Drivers may also notice that the diagnostic trouble code, DTC P0617, appears on their diagnostic scanner, indicating a problem that needs attention. Other potential symptoms include unusual voltage readings from the starter cut relay diagnosis line, which are above the expected threshold of 3.2 volts when the starter is off. Such symptoms may compound to create a scenario where drivers are unable to utilize their vehicles reliably, emphasizing the need for timely assessment and repair. In the first troubleshooting step for DTC P0617, begin by turning the vehicle to the on mode without starting the engine. This allows for diagnostic equipment to communicate with the vehicle's systems. Utilizing a Honda Diagnostic System HDS tool, check the value recorded for the starter cut relay. If this value exceeds 3.2 volts while the starter is turned off, it confirms that the failure has indeed duplicated, indicating an abnormal condition. The importance of this step lies in establishing a clear link between the observed symptoms and the underlying cause of the DTC. If the value is within acceptable limits, it suggests that further investigation into the physical components or wiring may be necessary. Next, proceed to inspect the relay circuit board specifically for the starter cut relay 1 circuit. It's essential to perform a relay circuit board test to determine whether it is functioning as intended. Check for any visible signs of damage or wear on the relay and surrounding components. If abnormalities are detected, addressing these issues will be necessary before further testing. Should the circuit show normal functionality, the next logical step would be to examine the wiring connected to the circuit for shorts or breakages. Detailed inspection procedures, as outlined in the service manual, are crucial at this stage to ensure accurate diagnosis and repair. Ensuring all connections are robust can help in identifying possible faults in the circuit. In this step, the focus shifts to the external circuit, involving the signal STRL1 to 2. This entails inspecting the wiring that facilitates communication between the relay circuit board and the PCM. Carefully examine the wires for any signs of wear, fraying, or damage that could lead to a short circuit or an open circuit condition. If shorts are detected, this could explain the high voltage readings previously observed. Additionally, use proper testing equipment to confirm continuity or the presence of any intermittent faults. If the wiring appears intact, but the circuit fails the test, then further investigation will be needed to isolate the problem within the components at either end of the signal path. This step is vital for ensuring that all electrical pathways are operational. The final troubleshooting step involves inspecting the powertrain control module, PCM, itself to determine if it is causing the abnormal readings. If previous inspection items indicated normal conditions, then the PCM is a likely candidate for the cause of DTC P0617. Begin by reviewing the operating parameters of the PCM against manufacturer specifications and diagnostic data. If discrepancies are found, they may validate that the PCM is indeed malfunctioning. Therefore, a comprehensive evaluation of the PCM inputs and outputs must be completed to ensure it communicates appropriately with the starter cut relay and other related systems. If the module is diagnosed as faulty, replacing it would typically resolve the issue and clear the DTC from memory. Once repairs are completed based on the troubleshooting steps, a final verification process is crucial. Start by using the Honda Diagnostics System, HDS, to clear the DTC from the vehicle's memory. This step is essential to reset the monitoring systems so that they can accurately log current operational statuses. After clearing, perform a test to ensure that the starter operates correctly without any hesitation or failure. Monitoring the output from the HDS during this period will confirm that the repairs have addressed the issues. It is also advisable to run a full diagnostic check again to see if any new or recurring DTCs are present. This comprehensive verification process will ensure that the vehicle is fully operational and properly functioning after the repairs. Preventive maintenance is key in avoiding future occurrences of DTC P0617. To mitigate risks, routinely inspect the wiring associated with the starter cut relay and PCM for signs of wear or damage. This proactive approach can help identify potential issues before they lead to operational failures. Another preventive measure involves checking the operations of relays periodically to ensure that they are functioning correctly. Regular diagnostics using HDS can assist in monitoring vehicle performance and can help detect irregularities before they escalate into more serious issues. Lastly, keeping up with software updates for the PCM can contribute to better reliability and performance of vehicle systems. In conclusion, addressing DTC P0617 in the Honda Civic 2022 and newer models requires a comprehensive understanding of the related components, including the starter cut relay, relay circuit board, and powertrain control module, PCM. Each plays a significant role in vehicle performance and functionality. Following structured troubleshooting steps allows for effective identification and resolution of the issue, thereby restoring the system to optimal operation. It's equally important to incorporate regular maintenance checks to prevent future DTC occurrences, ensuring long-term reliability of the vehicle. Lastly, being vigilant with diagnostic tools like HDS can make all the difference in spotting potential issues early on and maintaining vehicle integrity. Please like and subscribe to the channel. See you next time.